Hey class, today's notes are going to talk about properties of equality. Basically what this is saying is when we solve equations that we learned how to do really 2-3 years ago, there are proofs or there are reasons why we can do what we do. All right, so they've given those reasons names over here. It's going to tell us what they are or what it means. It's going to give an example, and then we're going to do an example in this column with actual numbers. So the addition property of equality, basically it's telling you if you add something to one side of the equal sign, you have to add it to the other. And we've been doing that for a long time, like x plus 7, let's do x minus 7 equals 14. To get x by itself, I would add 7, right? Addition property, I'm going to add 7 to both sides, okay? So next, subtraction property of equality. Well, if I added something to one side, I got to add to the other. Same thing with subtraction. If I'm going to solve this equation and I subtract 7 from one side, I have to subtract from the other side, and that's still equal. Multiplication property of equality. Again, you've done this before. All this says is you multiply by the same number to both sides of the equation. So if I had x over, I'm going to keep using 7. I don't know why, I like it. So if I had x over 7 equals 14, to solve that I would multiply this side by 7, but to make it equal, I'd have to multiply that side by 7. The division property of equality. So if I had 7x equals 14, I'm going to divide by 7 to get rid of the 7 on this side, but if I do it to that side, I have to do it to that side. So these are things that you've been using for a long, long time now. We're just making sure we understand what the names are, and then you'll see why we're doing this in the next set of notes. Excuse me, we're going to do something what's called proving equations, or why we can do things the way we do them. Reflexive property of equality. If A equals A, well, that makes sense, right? 7 equals 7. A number is always equal to itself. That's what it's saying right here. Symmetric property of equality. Well, if you notice, doesn't matter what side of the equal sign these two things are, they're going to still be equal. X equals 7, doesn't matter if I write it that way, 7 still equals x. Transitive property, if A equals B and B equals C, then A equals C. So basically it's saying if X equals 7, okay, and 7 equals, I'm going to use Y, well then these two things have to be equal also, okay? That makes sense? Because if x equals 7 and 7 equals y, or y equals 7, well then x and y have to equal one another also. Substitution property. A number may be substituted for its equal. So if x equals y, then y can be substituted for x in any expression. So for instance, if I've got, let me think of an example here. Basically, if it's telling me that x equals 7, okay, and then down here I've got 2x plus 7 equals, let's do 11. Oh, no, I'm sorry, y. Well, then I can plug this 7 in right here to figure out what y equals, right? So if x equals 7, I can substitute 7 into that x. If you'll notice, we're not solving any of these. We're just defining and giving examples of what these properties are. Our next set of notes, we're going to solve them, but we're going to say what properties we use along the way. All right, so let's go to the next page. The commutative property. So if A plus B equals B plus A. Basically, it's the commutative property of addition. It doesn't matter which order I add two numbers in. 2 plus 7 is going to be equal to 7 plus 2, right? They both equal 9. It didn't matter what order I added them in. The associative property of addition, kind of the same thing, but now we're going to use parentheses. 2 plus 7, if I put those in parentheses, plus 1 is going to be equal to 2 plus 7 plus 1. Sorry, I ran out of room there. So let's do it. So PEMDAS tells us we have to do parentheses first. Well, 2 plus 7 is 9. 9 plus 1 is 10. On this side, I got to do my parentheses first. 7 plus 1 is 8. 8 plus 2 is 10. So they both equal 10. Didn't matter. As long as I'm talking about addition, it didn't matter where the parentheses were. Additive identity property. A plus 0 equals A. So 7, any number plus 0, is always going to equal that number, right? Those two numbers are going to always equal if I add it to 0. Additive inverse property. So this is telling me if I take a number and then add the inverse of it or the opposite of it, remember that's from Unit 1, we talked about the opposites of number. The opposites of -3 is +3. So if I do 7 plus, well, the opposite would be, or the inverse would be -7. That's always going to equal 0. Basically, if these two numbers are the same, the only thing that's changing is the sign, then it's going to equal 0 if you're adding them. All right, next, the commutative property of multiplication. So all these dealt with addition, all these are going to deal with multiplication. Multiplication has the same type of property as addition in this regard. 2 times 7 is going to equal 7 times 2. Didn't matter what order I multiply them. 2 times 7 is 14. 7 times 2 is 14. Associative property of multiplication. Go kind of along with this one right here. Notice we didn't say that we have an associative property of subtraction, same as we don't have an associative property of division, but we do have one for addition and multiplication. So let's keep these numbers small here. So if I've got 2 times 3 in parentheses, that's telling me to do that first, times, we're going to do 4. So let's see, 2 times 3 is 6. 6 times 4 would be 24. That would equal to 2 times 3 times 4. See how the parentheses have switched places. So now I do 3 times 4 first. It's 12 times 2 is still 24. Again, this does not work with addition or subtraction. I'm sorry, this does not work with division, and this associative property of addition does not work with subtraction. Multiplicative identity property, basically saying if you take any number, multiply it by 1, you're going to get that number. 7 times 1 equals 7. So up here, 7 plus 0 gave you 7. That's the addition identity property. The multiplication identity property, 7 times 1, gives you 7. Multiplicative inverse property. So basically, it's telling you that if you take 1 over 7 and then multiply by the reciprocal, or flip that fraction, it's going to always equal 1. And here's why it works. Because I can cancel these two out or make them 1. 1 over 1 is going to give me 1. Well, so is 7 over 7 is going to give me 1. 1 times 1 is 1. 1 times 1 is 1. 1 over 1 is 1. So if you take a fraction, you flip it, multiply it together, you're always going to equal 1. Zero property of multiplication. If I take any number, multiply it times 0, I'm going to get 0. Distributive property. So we use this one a lot. If I've got a number outside parentheses and 2 numbers added together inside, it actually equals A times B plus A times C. For instance, if I've got 2 times, let's do x plus 7, that really equals 2 times x plus 2 times 7. Again, we use that one a lot, so that should look familiar to you. Exponential property of equality. Basically saying if I've got a number raised to a power, and then I've got that same number raised to another power, those two powers have to be equal. We don't use that one a whole lot, so we're not even going to do an example of that one. You will in Algebra 2, but not in Algebra 1. And that's the end of these notes. I'll be posting another set of notes here in a sec.